Hello everyone, Roommate here. As you can see, we have a bunch of enemies spawned in this circle. If you want to make a mob spawner like this, I'll help you doing that. These NPCs can follow you if you are close, and they will attack you if they are close enough. You can kill them and they will disappear after some time.
A few moments later.
Okay, and if you kill them all, let me kill them all real fast. After you kill all the enemies, you'll see that they'll respawn. Okay, they are all destroyed. Now they respawn. To achieve this, follow this video. Let's go. In order to make this, you'll need a library. You'll find everything in my repository. I'll give a link to the code that you'll need. You'll need to go to this repository. I'll put the link in the description, or if I'm not putting the link, just copy this link and paste it in your browser. Okay guys, let's get started. So the first thing you'll need is to make sure that you have the Explorer visible. In order to have the Explorer, go to View and click on the Explorer and the properties as well. Inside the Explorer, search for replicated storage, and here you want to make a new module script, and this module script should have folders inside, and click on this folder and press Ctrl D to duplicate the folder. Make this 3 times. Rename the folder by pressing F2. Name this folder classes. The second folder should be named functions. The third one should be named vendor. The module script should be named state machine. Good. Now let's go in the GitHub repository and go in the state machine and click on this state machine.lua. Press on the copy raw file. Click on this module, click inside the code, press Ctrl A to select everything, and then Ctrl V to paste the code that you just copied. Inside the classes, make another module script. Name this one by pressing F2 state, Ctrl D. This one should be named transition. Now press Ctrl D again and move this one here. Press Ctrl D again, move this one here. Ctrl D, Ctrl D. You should have 2 module scripts inside each folder. And let's rename this one to copy table. Let me check because I forgot. Go back to the folder functions. Oh, deep copy, sorry. My bad. Deep copy with lowercase d. You should keep in mind that if you don't type those as I'm showing, they will not work. Deep copy, and this one is merge tables. Good. In the vendor you'll have, let me check, you'll have signal and throw. Let's start with state. Go inside the state module, go inside classes, state, copy the raw file, Ctrl A, Ctrl V, go in transition, do the same, classes, transition, copy, Ctrl A, Ctrl V, deep copy, functions, deep copy, copy, paste, merge tables, functions, merge tables, copy, paste, signal, copy, paste, throw, copy, paste. Now we got everything. Close those folders, go inside your state machine, and then scroll up a little, and in order to check that everything is all right, type here state. It should autocomplete, transition, signal, throw, deep copy. Everything works fine. If it's not auto-completing, it means that you've done something wrong. Now, because we have our state machine, we should go inside the place and go on the avatar, rig builder, and click on block avatar. Open the rig, delete the animate local script, put the rig somewhere down, and then after you got the rig, you should rename it by pressing F2 to enemy NPC. Good. Let's go in server storage and make a folder for this enemy NPC. I think we should name this enemy NPC. Let's say model. Okay. Put it inside here. Then make another folder called state machine info. State machine. Let's keep it simple. Another folder called states and another folder called transitions. Good. Inside the states you'll need module script, and here you'll define all the states. Let me duplicate. So we'll have idle state, patrolling state, chasing state, attack state, dead state. And for the transitions we'll make them right now, but let's create another module script and put it inside here, as you can see. So let's rename this first module script. We'll name this idle. The third one should be patrolling. This one should be chasing. The fourth one should be attacking, or attack state. Let's name it attack. Idle, patrolling, chasing. Idle, patrolling, chasing, attack. Let's make another one real quick. This one will be dead. Good. We have all the states. Let's define an enum for our states. States enum. Good. Idle, patrolling, chasing, attack, dead. And inside the states enum, let's make module dot module dot patrolling, module dot chasing, module dot attack, module dot dead. And now you want to copy this string for each one, and then you want to copy the name, and now you have the enum, the states enum, and you'll need, let's create the first state, which will be idle. We'll need the replicated storage. Not required. It's game get service replicated storage. Copy the name, and then local. We'll need the state machine class, which has the types as well. It's require replicated storage dot state machine. Then we'll need the enum, and we have everything to define our state. Let's make local module equals, because it's a module script, we'll make our state. We'll use state machine dot state dot new, and here you put the state name, which you can find in states enum dot idle. After that, you have mode on enter. This is a function, so function this. Let's make a print. Let's copy this on enter. Let's say on enter, and the name of this state. I think module is a little bit weird. Let's name this state. Yeah, that's a lot better for me. State dot name. Oh, I forgot this. Now the idle state is completed. Let's make this for every state, and then go inside the patrolling and change this to patrolling, change this to chasing, change this to attack, and this to dead. Good. Now let's create a spawn area in our place. Go in home, go in part, select a cylinder, press 3 on the keyboard, scale this a little by dragging those dots, or better, go inside the part, rename it to spawn area, go to the properties, and then go to size, and this is the height. Let's make this 64 by 64, and now our cylinder is good to go. Go back to the properties. I want to make it transparent, not totally, but something like 0.8 should be fine. After you made your spawn area, which is a cylinder, as I said, place a script inside it. Rename this script to spawner. I think this will be good. Now go to your states. Let's say we'll need this. Go to spawner. Okay, replicated storage, state machine, and for this we'll also need the local server storage, game get service server storage, because we'll need the server storage to access the states enum and the model. Server storage dot enemy npc dot state machine dot states enum, and then we'll need local enemy model, which is indeed a model, equals server storage dot enemy npc dot model. Good, we got the model. We'll also need the area, the spawn area, which is a part, equals script dot parent, because this script is the child of this part, which is our area. Oh, I forgot something. Let's go with replicated storage and create a folder called utility functions. Make a module script inside here called go to just code, random point generator on cylinder surface, and then name this module script just like this. Get random point on cylinder surface, open the script, copy the code, paste the code here, and this function will take our cylinder two more parameters that are optional, and it will generate a vector which represents a random point on the surface of that cylinder. Now let's go back to our spawner, because we'll also need this. Local a equals require replicated storage. Let's put it here. I use it Alt and arrow keys to move the line up and down. Replicate storage dot utility functions dot get random point on cylinder surface, and we can name this the same. Good. Now we have this function. Let's make a function that will clone, that will make a spawn. Will spawn the enemy once. Local. Let's name this function local function spawn once. Hit enter. Type local clone, which is a model, and this clone will be enemy model clone. And this, let's make a position for this clone. Position equals get random point on cylinder surface. Oh, okay. Why is not? I think I forgot something in utility function. Yeah, I forgot to return the function. Return. We need to return this function in order to work. And now it should work. Yeah, it's working. We need a part, which is our spawn area. dy offset, let's make it 5, so it will be spawn 5 studs elevated a little bit higher from the surface, so it will not spawn in the ground. And the padding, let's make it 10, so it will not spawn near the circle margins. Okay, this is the clone position, which is a vector 3. Let's say clone dot primary part dot position equals clone position. And now that we got this, let's make another folder in the workspace. And let's take this folder also and make this folder the parent of our clone. And that should be it. As you can see, we have this function that will clone our enemy model. It will take a position inside the cylinder. It will assign that position to our clone, and the clone parent will become the workspace. Keep in mind that the order is important. If you do this, it can make bugs. So assign the parent of the clone after you assign the position. Good. Now if you close other tabs, now if you call this spawn once function, it should work. It should spawn a model on this, and it's working indeed. But let's make this anchor, and also let's make it can collide off, can touch off, can query off. Okay, and if we run again, you'll see that the NPC will be in this area. Good. Now we want to make a state machine for this NPC. So let's create one by using oh sorry, we'll also need the state machine folder with the states, but not so fast. Let me start by doing this. Local state machine equals state machine.new, and you'll need the initial state. States anon.idle will be our initial state, and the states you need a table with all the states of the enemy, and the states that the enemy can have are those we defined earlier. So use state machine, a column, below directory, and here you should put a directory in which the states are defined. For us, they are in server storage enemy npc state machine states. They are here, and after that we'll also need an initial data. But this low directory, let's make this Ctrl+X, local defined states equals states low directory this, and then define states can be used here. And then after that, let's make a table which will represent our initial data. The initial data should be our clone model. So let's name this npc model equals clone. Let's say we'll also need the, what do we need? We need a model, and I think we need only the model probably. Oh yeah, I remember what I was doing. npc area, npc spawn area equals spawn area. Yeah, we'll need this because we want to generate points on this area. And that's it. That's the data we'll need for our, how can I say, for our state machine. This is the initial data you'll need. Now, if you go in the idle, this state, because it's the first state, we define the state machine to start from this state. So it means that we should see on enter for the idle state. If we run, but there is no state by the name of idle. Oh, wait, states. Why is not? Oh, I know why. My bad, guys. Sorry. You have to say return state for every state over here. So go here, return state, go here, return state, go here, return state, go here, return state. And now we can do the local defined states equals state machine load directory blah blah blah, and use those defined states here. And now if you run, you'll see that we got our entered our NPCs in the idle state. So now we'll need transitions for our from idle to, so basically when you enter in idle state, you want to do nothing, right? But you'll also want to move from idle to chasing after a fixed amount of time or a random amount of time. A good way to do this is to use self. With the self keyword will access the state, and let's make a property inside the state, self.timer equals 0, and then say something like state heartbeat on heartbeat, sorry, and this is a function also, and this has a parameter data and delta time. Delta time is a number for what function. Okay, data is a table with string keys and any data. Let me check again. I think I'm right. And delta time is used to increase this timer. We can make something like if self dot timer less than, oh, I have a better idea. Self, when you enter in the idle state, you want to make a random amount of time that needs to pass before entering in the chasing state. Let's make random wait time equals random dot new or next integer, something between 1 and 3 seconds should be good. And if self dot timer is less than self dot random wait time, then self dot timer, we add the delta time in the timer. So this means that the time will increase. It means we add time in this state. The longer you stay in this state, the more time you'll have added in this timer. Delta time on heartbeat will be called every frame, kind of, and delta time will be a small number that will represent the time in seconds that passed since the last frame, and this timer will add that time, that delta time, and it will be kind of like a time measurement. And you make sure that if this timer is less than this random wait time, which is 1 or 3 seconds, then we add this delta time and we return from this function. We want to switch from this state to a different state. Let's test this. So basically in this idle, you want to change your state from idle to patrolling a random amount of time. So we are in idle, and after 1 or 3 seconds we are inside patrolling. We'll need some transitions. Let's make the most important transition, which is I think is dead transition. Let's make this one. To make this dead transition, let's name it died. So basically, if the NPC died, we are basically stopping. We are basically going to the dead state. So we need a replicated state machine, states enum. Let's make our local transition state machine dot transition dot new, and the target state should be states enum dot dead. Basically, this transition will bring us to the dead state. and you need transition on data changed. This will be called very often and it will test that we should change or not the transition. And we also need the data here, if I'm remembering right. I hope so. Let me delete this. You'll have data, yeah, data, and then using this data we can access the humanoid of our model by saying data.npc model humanoid, and this data, not sure why. Okay, we have the humanoid, and we can say if humanoid dot health bigger than 0, then return false, otherwise return true. So basically we check the health of our humanoid. If the health is bigger than 0, we return false, so we will not change to the dead transition, otherwise we return true, because it means that our NPC died. And in order to change from idle or patrolling, we need to add this transition. So we'll need another local transitions requires script.parent transitions transactions. What transitions? My bad. See, my bad. Transitions. Good. So we have the transitions directory, and we are going to use those transitions directory for our state. We say state.transitions equals require transitions died, and we forgot to return the transition again. Let's return the transition. Okay, idle. We have transition now. So basically when you are in the idle state, you will go to the dead state if you die. And let's make this for the patrolling as well. Let's make this and also copy the requirement. Good. And if you click, oh, we don't have a weapon. Let's go to the toolbox. Let's search for inventory. I need the sword from Roblox, and we need this inside the workspace. Okay, we placed it in the starter pack. I want to make sure that it's made by Roblox, creator Roblox, so this is safe. We have that sword inside our starter pack, classic sword. Good. Now we can kill our enemy. We have the idle, the patrolling, and we have a state, heartbeat, timer. Okay. So basically we can die from any state you can die. That's important. Let's go and hit play. Let's check the output. What? Attempt to call require with invalid arguments. Find out transition. Okay, return transition. What is going on? Attempt to call require with invalid arguments. What? These transitions, and I require these transitions that died. Replicated storage. Station. Let me rename this real quick. Okay. What? Okay. Oh, my bad. I placed required here. I don't need to require this. Now it should work. But also we had that problem there, so we fixed it. Now it should be fine. Patrolling, change state patrolling, and now if we hit play, attempt to index nil with humanoid. Why is that? So I have the NPC model, and then you try to access the humanoid data NPC model. Line 8. I think that NPC model should be inside data NPC. Oh, I typed NPC model. My bad again, guys. That's my bad. Attempt to change to patrolling, but there is no state by the name patrolling. What? State machine inside here. What do you mean is no state by the name patrolling? Oh, we have the same problem here. Transition, and then died. Why is changing so fast? Oh my god, my ears. Let me make this a little bit. Okay, now let's open the output, and you'll see that from idle you'll go to dead after you kill it. Let's make the idle a little bit longer, so you'll see that you go from idle. Okay, we are in idle, and then it will go to patrolling, and then after I kill it, it will go to dead. Oh, what else do we need? We will need to make this patrolling take a random point and move toward that point. Let's do that. go inside the patrolling, and on enter should generate a random point using that function. So first thing, let's get that function. Local require replicated storage utility functions get random point. Okay, now when you enter on patrolling, you need self target point, get random point on surface, and the surface is data. Oh, I forgot to put the data here. Data.npc spawn area, if I remember it right. npc spawn area, and then the y offset should be 5 and the padding should be 10, or for us it can be 0 also or not. Okay, we made this. Now that we have this, we can say something like data. I think we don't need this self. Let's say local target data.npc model dot humanoid move to, and let's say target, and when you finish this you go back to idle. Let's say local humanoid equals this, and we should say that this is a humanoid indeed, and then humanoid move to target, and then humanoid that move to finish the column wait. We wait for this, and after this is done we say self change state, and then states enum.idle. So basically we generate a target inside this npc spawn area. We try to move near that target, and then we wait for the movement to finish. After that we change state back to idle. So basically we'll go back and forth between idle and patrolling, and each of those two states have the died transition, so you can die from idle or patrolling states. Let's hit play. You will see that our npc selects a target point, it moves there, it stays in place, then it goes in another place. If we kill, let's see the output. You'll see idle, patrolling. Oh, I killed it only using the sword and it's dead now. That was weird. The sword is acting weird. But anyways, let's go to the dead state, and when you enter in the dead state, it will be nice to have a task that wait for maybe 4 seconds or 3 seconds, and then you say something like data, which we don't have. Let's place data here. npc model destroy. We destroy the model after 3 seconds, and then we say something like data dot dead on enter executed equals true. So basically we'll tell the state that this task that wait finished destroying the npc model, so we can listen outside of our state machine for this data change event. Let's copy this property name and let's go inside our spawner, and here you can say something like state machine dot data changed, or where is the data changed event? If I type change, data changed is a signal, and you say connect something like this function. The function takes the new data, the index, the new value, and the old value, but we need only the new value and the index. Index is string, by the way, so we can say something like if index not equal this index, then return. Otherwise, if that's dead state on enter executed, when this dead state on enter executed, we want to let's go back to dead state. So we have another important thing to do. State can change state, it's a virtual, this is a function, and return false, because after you died you can't revive yourself. You died, and we prevent the change of the state by returning false in this function. Good. Now that state on enter executed should make our state machine destroy. We should destroy our state machine because we died and we executed the dead state enter method. Let's test it. So we are in idle, as you can see. If I is patrolling, is back in the idle, patrolling again, idle again, let's kill him while he's patrolling. So he was in patrolling and he died, and after a while he get despawned. Let's hit the stop button. Let's go back to our spawner, and here it will be cool to make a task that wait for maybe 5 seconds and then respawn our how can I say, spawn once. Let's recall this function, so after the NPC died, he will get respawned after 5 seconds in this area. And if you want to make multiple enemies, you can say for I equals, for what, from 1 to let's say 20 enemies, for my document, then hit play. Now we should have 20 enemies spawned. They are walking. As you can see, some of them are flying, but they will come back. No worries, they'll eventually come back. Yeah, let's kill all of them. You'll see the fact that they will get respawned even if you kill them. So basically, when one of those little guys are dying, they'll get respawned. Can you see? Okay. It will be cool to make a transparency spawn effect. Oh, they are not getting respawned. Why? Let me check something real quick. So basically, oh, I think I know why. Because without this, this event will not be fired, and the first implementation should be fine. So we destroy this state machine. We wait for 5 seconds, then we spawn again the enemy. Let's test with 3 enemies only, and hit play. Yeah, okay, he's dead. He got respawned. So it's working. Let's kill all of them. You'll see that they will respawn one after another. The next step will be to make the enemy follow us when we are close. So in order to do this, let's review the code that we wrote so far. So when you die, the state machine gets destroyed. You wait for 5 seconds and then you spawn another NPC. And here you destroy after 3 seconds the NPC. Let's make this 2 seconds. Okay, so now we need when you are idling or when you are patrolling, we'll need another transition. Control D to make another transition. Let's name this so player. Basically, the enemy saw you and he will start following you. So player will bring our state machine to the chasing state, and then you will want to have the players service. It's game get service players. So we'll take all the players, and then on data changed. So basically you have self in the transition, right? Or not? Let's not use the self keyword inside this transition. You want to make something like a quick check for players, but this should happen periodically, like for in player get players. Basically you will take all the players, you take the character which is a model, and you say p.character. You say something like if character, because it can be null if the player is not loaded yet. If not character, then continue. If you have the character, you say something like you'll need the root part, the primary part, which is a part, base part, equals character dot primary part. I know that this exists, so we no longer need this. And if you have the primary part, you'll also need the, let's name this player primary part. You will need the NPC primary part, so let's get the NPC also. Local NPC model equals data model, and this is a model, and you will need the local NPC primary part equals NPC model dot primary part. We have both the primary parts, and now we need to check the distances. We say something like, let me make some space here. If NPC primary part dot position minus player primary part dot magnitude, if this magnitude, which is the equivalent for distance, is less than a fixed value, let's say 20, then we start following the player. We say data dot scene. The scene player should be the player, and then return true. otherwise we return false, because we have looked through all the players and we haven't found any player that is near to the NPC's primary part. We have this new transition, so player, and this so player should bring us to chasing. Let's test it. So let's put, you can see a player when you're idle. Let's make it require transition dot so player. Let me translate the scene player real quick if it sounds right. If I say this, okay. So player. So basically, when you saw a player from idle, you'll go to the chasing, and when you are in patrolling, you can saw player as well. And when you are chasing, you'll chase him, but not so fast. Let me check it. Let me check if it's working. But first, let's make this a little bit smaller. Let's spawn only one enemy. Okay, it's idle, patrolling, chasing. He saw me. Good, that's good. Because he saw me, now we should make him follow. So when you enter in this chasing phase, I think we don't need the chasing. We need a state on heartbeat. We need the data, and let's make a function. And this function will help our NPC to follow our player. To do this, we'll take the local, which is a humanoid, and basically you'll say something like data.npc model and you'll say humanoid move to data.scene player. Okay, and this player has a character, and this character has a primary part, and this primary part has a position. So basically you want to move to the position of the player's character primary part. Yeah, I know it's a lot. Yeah, anyways, I want to keep this also just in case. On enter, and you want to leave from this chasing state, but let's test it first. He's in idle. He starts chasing me because he's locked on me. He's seen me. He saw me, sorry, and I am the scene player now, and he will follow me. I think I'll make this a little bit the errors are because when you disconnect, it tries to go to your primary part, but the primary part is no longer there because you disconnected. Not a big deal. I want to make the NPC slower because he's too fast. Let's go in the server storage model, go inside humanoid properties. Let me test something. Oh, that's better. And then go to the walk speed and make it like 8. Good. Now we have a slower. Yeah, it should be slower. Let's test with the new speed. Yeah, that's better. We can run away from this model now. We can also kill him, and he will get respawned real quick. Oh, he will not because he died while he was chasing me, and I forgot to put the transition. Let me fix that real quick by going to chasing, I mean idle, and copy this as well. Go to, oh, we need this first. Go to chasing, add the transitions directory, type state dot transitions equals require transitions dot died. So basically you can die while you are chasing. Let's test this. He died while he was chasing and he got respawned. Good. We can see a player while we are idling, while we are patrolling, while we are chasing. We are not scanning for players when we are chasing because we already found one to chase. But we want to make sure that so basically here we can check, we can take the local player character, which is a model, equals this piece of code from here, and we can take the player, I mean we only need a primary part. Let's say player primary part, so we no longer need this, and this primary part is a base part. And now we can take the NPC primary, which is also base part, can be found in this piece of code, that primary part. And while you are chasing, you can check the distance between you and the player, and if the distance is too big, you can give up on chasing. So you go back to idle state or patrolling. So in order to do this, let's say something like local. I think we should better say player position npc position, and this primary part dot position, primary part dot position. This is a vector 3, this is a vector 3, and you can say something like if player position minus npc position dot magnitude it's greater than, let's say, 13, then we give up. We say self change states enum, and we go back to idle. Or even better, we can go back to patrolling, so it will start moving right away. It will choose a random point on the area. Okay, and then return. Otherwise, we take the humanoid of our npc model and we go to the player position. It means we'll follow the player. So right now you can die from the chasing. Okay, now you can play, and as you can see, we have the model patrolling. He start chasing us. If we get too far away, he will start patrolling again. He's chasing us again, patrolling, chasing, patrolling, chasing. Yeah, that's cool. Think I like this implementation. The next thing we want to do is to move from chasing to attacking. So when you chase a player, you can either go to, you know what, I have a better idea. Let's calculate the magnitude like this. Let's make a distance using this, and you say something like if distance is greater than 13, then go back to patrolling, and you'll have another if distance is, let's say, lower than 5, lower than 6, we'll go to attacking. So while you are, if you are too far away, you'll go back to patrolling. If you are very close, you'll start attacking the player that you've seen. Otherwise, you'll keep moving if you are between those two values. So when you chase, that's it. Let's go to attack. Make sure you copy the transition. We'll need the transition for the attack. Chasing. So we are moving from attack transitions. Let me see something. Okay, so now we are in the attack state. You can die while you are attacking. So now while you attack, you have the player to attack. I would like to make this attack. When you enter in this attack state, it will be cool to take the npc humanoid equals, let's take the data. You have data dot npc model dot humanoid. So basically you'll take the model of the npc, the humanoid, and it will be really cool if you say something like npc move to, and I'll move him to his position. Basically I'll make him stop from moving because he was chasing, he's still following us, but if you get close enough, I'll make him stop so he can attack when he enters into the attack state. And to make this, we can say data.npc model.primary part position. This line of code will make the npc stop moving because we'll move him right where he is already. We can say state on data change, state on herbit data delta time function. We know that we have the player. We can check using this as well, the attack. So we take the position, we calculate the distance between the npc and the player, and if the position is, before doing that, let's say we have a timer in this. Because it's the first hit, he will hit you once. You can say something like if self.timer and self.timer less than 5, every 5 seconds he will attack you. Let's say 2 seconds. We'll add the delta time to the timer and we return. We do nothing. Otherwise, we say that timer equals 0. It means that we start again to count. We calculate the distance between the player and the, I think chasing should have a smaller distance, something like 3 or 4, and the attack should have a distance of 6 or 7. Yeah, That makes sense, because if the NPC stops, he will he will not have time to attack you. And now you can say something like, if distance is greater than 6, it means that you got too far, and you can type change state to states enum dot. He'll start chasing you again, and I'll return. Otherwise, we have the player, and we can deal damage to him by using this. Let's give 5 damage or something like that. Character take damage, and let's give 5 damage to our player. So basically, from the attack, you can go back to chasing when the distance is too big for another attack. Let's test this. So the model is in idle. He will start patrolling. He will see us. He will attack again. He will start following. He will attack. Why is not attacking still right away? So basically, okay, he'll follow me. He's patrolling now because he lost me. He's chasing. He's attacking me now. Okay. That's good. He's attacking me again. I'm attacking him also. He is dead. He got respawned. He attacks me again. Okay, so we are good. Our NPC works fine. Thanks for watching, guys. I'm kidding. I come back. Let's test with multiple enemies. If we make 10 enemies, let's see how they are behaving. So basically the attack. Can you die? Yes. Make sure that you can die from each of these states, because it's very important. You don't want an unkillable NPC in your game. Now we have 10 NPCs. Let's test them. As you can see, they are working just fine. They start chasing. Let's make them chase. Yeah, they're all chasing me now. Yeah, it's working. So that was the video. Thanks for watching. And if you want to know how you can copy this area and place it in multiple places, like so, let me show you, like this, and you want an optimized code that will make the enemies that are too far away not moving, I will make another video about this topic. Just let me know in the comment section.